So this is problem number 4 from problem set 3.2. We did this in class, but I'm going to go over it again right here. Let's see, we have a ball thrown straight down from a position 20 meters above the ground, and you know how fast it was thrown. We want to know how long does it take to reach the ground, and what's the speed of the ball when it strikes the ground. So, I'm going to draw a picture, first of all, which would strongly suggest that y'all do the same. Okay. It's Stickman Physics. There's actually somebody online, I think. Anyway, so then, so this is given an initial velocity straight down. So that's V naught. So then you need to decide on a coordinate system. And usually that coordinate system is centered on the object in question. It doesn't have to be, though. So here's my coordinate system. And although right now we're just doing motion in one dimension, in a few weeks we'll be doing motion in 2 dimensions, so you'll definitely need an X and a Y axis. And again, you need to choose what direction you want to be the positive direction. It's up to you, but in some problems, one direction might be a little easier to set things up than the other. In this case, the displacement of the ball is down. The acceleration of the ball is down. The initial velocity of the ball is also directed down. So I'm going to let down be positive here. So just to remind myself, that's the positive direction. Okay. And so now I can write down some things. Well, yeah, I know V naught is 5 meters per second. I also know that once the ball leaves my hand, it's accelerating downward at about 10 meters per second squared. I also know the displacement of that ball. I'm calling it delta y. And since that displacement is downward, it's going to be positive 20 meters. Okay, so we want to know how long does it take to reach the ground. That's time. And here's one way you could get time. Because if you look at your handy-dandy little list of equations, there are 4 of them, right? Maybe 5, but definitely this is one of them. Delta y is equal to V naught times t plus 1/2 at squared. Oh no, why is that a delta y instead of a delta x? Well, because it's a vertical displacement. It's the same equation. And so notice here, I know everything here except t. So this is one equation and one unknown. You could write it like this. And I'm going to leave off the dimensions here. So 20 is equal to 5t plus, well, this is 1/2 of 10. And 1/2 of 10 is 5. 5t squared. See, that's a quadratic equation. And if you know how to use the quadratic formula, then boom, plug this in here and you can solve for t. But I'm going to show you another way to get t, and that involves finding the second one here first. You don't need to find these in order of the questions what they're asking here. So what I'm going to show you is a way to do this that doesn't involve solving a quadratic equation, because that can be a little scary sometimes initially. So here we go. I'm going to find V final, the speed of the ball just as it hits the ground. V final. And so, wait a second, I don't know what t is. That's okay, because we have an equation for V final that doesn't involve t. That equation, which is also in your list, looks like this. V final squared is equal to V naught squared plus 2a delta y. And so, yeah, I know everything. I know all of these. I know V naught, I know the acceleration, I know delta y. So then V final squared is equal to, V naught was 5 meters per second. That's squared, plus 2. The acceleration is 10 meters per second squared. And my delta y is 20 meters. All right, so then V final squared is, well, 5 squared is 25. And the dimensions are meters squared over seconds squared. Because if you square, you have to square everything in here, including the dimensions or units. So meters squared over seconds squared plus, let's see, 2 times 10 is 20, and 20 times 20 is 400. So that's plus 400. And the dimensions are, well, a meter times a meter is a meter squared. And then downstairs is second squared, which is a good thing. Because to add quantities, they have to have the same dimensions. So then I have V final squared is equal to 425 meters squared over seconds squared. And then finally, to get the V final by itself, I take the square root of both sides. So I have V final is equal to, remember, you got to do the plus or minus thing just in case, square root of 425 meters squared over seconds squared. So let's see, 420, it's going to be just a little over 20. .6. And because the ball is moving downward when it just before it hits the ground, that's the positive direction. So I'll choose the positive root here. 20.6. And then when you take the square root of meters squared over seconds squared, it turns into meters over seconds. All right, so there's V final. Now I can use this to find the time. All right, so I have this other expression we use, which is the definition here of acceleration. It's V final minus V naught over t. So then to get the t by itself, multiply both sides by t, divide both sides by a, and that's going to cancel the t over here and cancel the a over here. That's algebra. And then so I get t is equal to V final minus V naught over a. So now I can plug in some numbers. So let's see, so my V final was 20.6 meters per second minus my V naught was 5 meters per second. And then my acceleration is about 10 meters per second squared. Okay, so 20.6 minus 5 is 15.6 meters per second divided by 10 meters per second squared. 15.6 divided by 10 is 1.56. And then dimension-wise, that m cancels that m. This seconds cancels one of these seconds. And then I've got basically 1 over seconds, which guess what? It's seconds. So there you go. Second part of that problem is done now. You should view and review and then review and then re-review this problem. You can learn how to do these, but it takes practice. So there you go. Gonzo out.